Today's first talk is given by Zhao from Galaxea, and also he's an assistant professor at Tsinghua University. And he's going to talk about recent attempt or discoveries by Galaxea on the robotics regime. So please give a big hands and welcome Zhao.
Hi everyone, I'm Zhao. I'm a co-founder of Galaxea and the diamond sponsor of this CORL conference, and I'm also an assistant professor at Tsinghua University. Today I would like to share our journey at the intersection of robots, data, and foundation models. At Galaxea, our goal is to shape the robotic ecosystem with three pillars: hardware, models, and tools. On the supply side, we cover everything from motors to teleoperation systems to data and models. And our products combine three elements: robots as the physical embodiment, and our pre-trained foundation model as the brain, and post-training tools for evaluation, fine-tuning, and deployment. On the market side, we work with both enterprise clients and the developers, building what we call robotic application ecosystem, empowering others to accelerate the embodied AI industry. To support this vision, we have already built R1 series of robots. On the left-hand side is our R1 Pro robot, our next-generation humanoid platform designed for navigation, manipulation, and complex embodied tasks. And on the right-hand side is R1 Lite, a mobile manipulator that shares the same software stack but comes in a more compact and a scalable form. You are welcome to take a look at our robots in our booth in the exhibition. Of course, the robots only matter when people actually use them. That is why we have worked very closely with universities, research labs on developing applications on our robots. Here are some examples of research papers from these universities and research labs. And we have also a lot of industry partners. Here are some demonstrations of industrial tasks and autonomous workflows. And here are some featured partners. At Stanford, people are exploring household tasks with our robots. They developed a model called Whole Body VIMA with a teleoperation system called Joylo, and they have also released a behavior dataset. And the Beijing Academy of AI has recently released a VOA model called RoboBrainX, which demonstrates the zero-shot generalization and lightweight fine-tuning capabilities for solving complex tasks. And physical intelligence also developed their Pi05 model with open world generalization on our platform. And up to now, our Galaxea robotics community has over 100 customers globally. Now, let me turn into our own efforts in intelligence. 2 months ago, that we open source Galaxea open world dataset and G0 dual system VOA model. The Galaxea open world dataset is the world's first dataset that is open source that's collected in the open world environments: apartments, hotels, offices, and warehouses. And with this dataset, we train our G0 VLA with the dataset, and the model generalizes well in downstream tasks with few-shot capability, including challenging whole-body manipulation tasks like making the bed. Here are some tasks that are trained with only 20 episodes or trajectories. Okay, and since we released the Galaxy open world dataset, it has been downloaded more than 120,000 times, ranking #1 globally on Hugging Face and the Model Scope. This shows the community's demand for authentic embodied data. And more details about our VOA model. Our G0 dual system VOA model has a slow thinking VOM that handles language understanding and task planning, and also has a fast execution system that does real-time motion planning and closed loop control. Together, they allow a reasoning at 2 Hz and planning and control at 20 Hz, just like humans think slowly but act quickly. To train the model well, we designed a 3-stage training pipeline. The first stage is cross-embodiment pre-training with cross-embodiment robot data. This stage is trained in an autoregressive way, and we find that action tokenization is actually the key ingredient in this process. And the second stage, pre-training stage, is single embodiment pre-training, where we use our Galaxy open world dataset to pre-train the model. And finally, the post-training stage only requires 20 to 100 task trajectories. Finally, I would like to share some lessons that we have learned during this process. The first lesson that we learned is about the data. That the robot data, we are actually suffering from a new domain gap that is called real-to-real gap in data collection. In order to scale data collection, many companies today, they are trying to build in-house robot data collection site so that they can collect data more efficiently. However, the real homes are messy and unpredictable compared to the robot data collection site. If the robots are going to succeed in real life, our data must reflect their reality. This is why we also emphasize open world, messy, and long horizon data collection. This echoes Professor Jitendra's Airbnb challenge, that if you want to succeed, if you really succeed in an Airbnb home, and then your robot really generalizes. Another important lesson is about evaluation. The evaluation must be standardized, and it is so important to benchmark the progress of our models. However, robotics is a very complex system. Tiny differences in the hardware or environment can lead to huge differences in the results. So this is a system engineering instead of model engineering. So we took 3 best practices. First, every time that we are going to start the evaluation, we will perform log replay on the robot. And we find it to be a very good sanity check on the environment settings, and also the robot postures and the positions. Second, in order to ensure a high success rate in the closed loop evaluation, the first thing that we need to do is actually high performance open loop evaluation. If we get a good number in open loop evaluation, then it is more likely it will succeed in the real world. And third, parallel evaluation across models is also very important. Every time you do the evaluation, don't just do evaluation on one model, but on multiple models. Because each experiment, between the different experiments, there are tiny, tiny differences. In order to make sure that they are close enough, do all the experiments, evaluations at the same time so that you get the rankings of the models correctly. Looking ahead, we are at very early stage of this journey, and we are expanding our open source roadmaps. Next month, October 2025, we'll have more open source plans. Here's a preview. First, we're going to open source another 500 hours of R1 Pro data, in total reaching 1,000 hours of data with more comprehensive annotations. And in terms of models, we'll release new models, G0 models with different model sizes. And we will also release G0 Plus with zero-shot pick-and-place generalization capability. Finally, we'll also open source more tools, such as cross-robot calibration and high-performance inference code, so that our developers can use the robots more easily. The goal is to lower the barrier for the whole community so that everyone can build on top of Galaxea's robot. That's everything that I have for today. If you are interested in us, in our company, please follow us on X.